Okay, so we have talked about the properties of addition. We talked a little bit about closure and what that means. So I want you guys to look here at example 1, and I want you to attempt these problems just by the knowledge that you have now about what it means to be a closed set. And then we'll come back together and see if you're right. So go ahead and press pause now. Alright, so I hope that you had paused the video and tried these problems, and now let's see where we're at. So for part A, or well, let's read the directions first because that's extremely important. It says, which of the following sets are closed under addition? So before we can do this, we have to understand what closed means. And remember, a closed set is something that if you take any two items in the set and you add them together, because this is under addition, that you get a answer that is in the set. So you have to understand that idea before we can start in working on this. Now the second part of this says if a set is not closed under addition, explain why not. Alright, so here for our first problem, we have the set which is called B equals the set that has the element 0 in it. Well, if 0 is the only element of the set, then we can only add 0 to itself, 0. So if I say 0 plus 0, that gives me 0. So when I add any two things in the set, I get an answer that is also in the set. So yes, this is closed under addition. For part B, it gives you a formula. And B says that we're talking about the set T, which is the set of 3n, so it gives you the formula. Remember that straight line means such that the n is an element of the whole numbers. So remember, your whole numbers would be like 0, 1, 2, 3, dot, 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 on and on and on and on and on. Okay, so if I were to write out a few of these terms, if I were to start off with 0, 3 times 0 would be 0. If I were to then go 1, 3 times 1 would be 3. If I were to then use 2 for my n, 3 times 2 would be 6. If I were to use a 3, 3 times 3 would be 9. Let's just do a few more. If I were to use 4, 3 times 4 would be 12. If I were to use a 5, 3 times 5 would be 15. If I were to use a 6, 3 times 6 would be 18, and so on and so forth. So this is really the set that we're looking at. Okay, so if we're trying to decide is that set closed or not, if I were to choose any two numbers in that set, the answer has to also be in that set. So if I were to take, say, 0 plus 3, well, that would be 3, which is in the set, so that works. What if I were to take 6 plus 3? I would get 9, which is in the set. What if I were to do 6 plus 6? That would be 12, which is in the set. What if I were to do 9 plus 6? That would be 15, which is in the set. So I could go through and I could add any of the numbers in this set together, and I would end up with an answer that is also in the set. So yes, that is a closed set under addition. For part C, we have this set N that is 1, 2, 3, 4, 5, so on and so forth, 6, 7, 8, 9, 10, on and on and on and on and on. Okay, so if I choose any of those numbers in that set, say a 1 and a 5, if I add those together, I get 6, which would be in this set, because remember, this just keeps going on forever. What if I were to do 1 plus 2? I'd get 3. What if I were to do 4 plus 2? I would get 6, which would be the next number in the list. So yes, this set is closed under addition. What about the next set? The next set, V equals 3, 5, 7. What do you think about this one? This one is not closed under addition, because if I were to take any two things in the set, say 3 plus 5, that would be 8, and 8 is not in this set. This is a finite set. Remember, it has a specific stopping point. So 3 plus 5 would be 8. That's not in the set, so that's one example. If I were to do 3 plus 3, that would be 9, and that's not in the set. 7 plus 3 would be 10, and that's not in the set. So as long as I come up with one example, so 8 is not an element of V. So that shows you that that is not a closed set. What about part E? Again, this is set builder notation, so it says the set of all x's such that x is an element of the whole numbers and x is greater than 10. So it's not 10, doesn't say equal to, it's greater than 10. So the next whole number greater than 10 would be 11. And then the next whole number past that would be 12, and then 13, and then 14, and 15, and so on and so forth. So that's the set that we're talking about. Okay, so we need to decide, is it closed or not? If I were to take any of these numbers and add them together, would I get a number in this set? Well, it looks like it's going to be every, complete, what we think of as being whole numbers that starts with 11 and goes on for infinity. So if I were to add 11 and 11, I'd get 22, which is going to be somewhere over here in the set. Yes, this is closed under addition. And then finally we have the set C that is composed of only the elements 0 and 1. So what do you think about this set? Is it closed or not? This set would not be closed. That's right, because if I were to take, say, 0 plus 0, I would get 0, and that's in the set, so that's fine. 0 plus 1 would be 1, and that is in the set, so that's fine. But what if I took 1 plus 1? I would get 2, which is not in the set. So 1 plus 1 equals 2, which is not an element of C. Not an element. So that I just found an example where that doesn't work. So we can say that that's not a closed set.